Welcome to the Typhoon-class SSBN subbrief. As it says here on the slide, it was built by the Russian Navy, back then it was the Soviet Navy, in response to our United States announced Ohio-class and our subsequent follow-through with building it. They wanted to counter that. They had been building the Delta series, that we also have a series on, and they wanted to kind of outmatch us. And boy, did they. They built a behemoth of a submarine. They built 6 of these. They were building number 7 before they ran out of money, and they scrapped the 7th one. So 6 of these prowled the oceans during and after the Cold War. So the boat designation is 941, Project 941. The Soviets called it Project Akula, Shark. The NATO called it Typhoon, which is why we call it Typhoon here on this channel, because we use NATO names. But that has caused some confusion because there is a NATO designation for another submarine that is an attack submarine, does not have anything to do with ballistic missiles, that NATO calls Akula. So if you're not from the United States or a NATO nation and you hear the name Akula, you could be thinking of a Typhoon, or what we in the West call a Typhoon. So just understand that this is a Typhoon, and if you're from the Soviet era, you may call this the Akula. It was built and designed by the Rubin Design Bureau. They did all of the ballistic missile submarines, all the Deltas. They designed the Yankee. Rubin Design Bureau is absolutely famous for outstanding submarine designs. Put your biases aside. They were great engineers, the people that worked at the Rubin Design Bureau. Yep. This submarine displaced over 26,000 tons when it was submerged. It was enormous. We're talking like 1.5 to 2 Ohio classes. The thing is so big. It is nuclear powered. It does have 6 torpedo tubes. It's got 4 53-centimeter tubes that, whenever you think of a 53-centimeter torpedo, think of it, it's multitask. It can shoot submarines. It can sink surface ships. It does it all. 65-centimeter torpedo tubes are huge torpedoes that generally go after ships, primarily aircraft carriers. That's why they're so big. They have an enormous warhead. That's the extra size. But they also have a larger engine, and more importantly, a lot more fuel. So they can run, 65-centimeter torpedoes will run up to an hour, 60 minutes, straight run, high speed. And because of that, because of their endurance, they're often a wake-homing torpedo. So you can launch them in the general vicinity of a fleet from miles away. And for the next 60 minutes, that fleet or portions of that fleet is more worried about running from your torpedo while you get away. Sometimes these are defensive weapons used in this type of situation because the ballistic missile submarine is not interested in sinking the fleet with torpedoes. It's not an attack boat, but it is interested in getting the heck away from a fleet or an ASW hunter-killer group. And so if they shot 1 or 2 of these wake-coming torpedoes in the direction of a NATO fleet looking for them, they would buy them up to an hour. And that's how that was employed. So what missile did they shoot? They shot the Bulava ICBM, intercontinental ballistic missile, SSN-20, and they carried 20 of these. So very easy to remember what type of missile it was. SSN-20 carries 20 of them on the Typhoon. RSM-39 and RSM-56 are the 2 different variants that we'll go into detail today. The Test 71 and 53 series of torpedoes, again, we're going to go into detail. They carried 22 torpedoes or missiles on board, and the last boat was decommissioned in February of this year. Yeah, they kept it on as a test platform. So here is the general layout, and if you're only listening to this, you may want to skip ahead a little bit because you really need to see the visual to understand what we're about to do. We're going to start at the bow. That's the front of the submarine and work our way back. Okay. And so we're going to go along the top front side of the submarine and work our way back. So number 1, the light blue shaded area is the outer hull. This is a 2-hulled submarine with multiple 5 specifically pressure vessels. Pressure vessels are where the people are. So you have an outer hull that holds all 5 of these things that are welded together in an outer shell that protects it. And there's free flood area. Water gets into where you see all the blue. That's all salt water when it's submerged. All of it. The only part that's dry are the missile tubes in gray and the yellow part where the people are. You may notice the reactor is blue. That's because it's water cooled. So blue water. All right. Number 2, those are the 653 centimeter torpedo tubes. 2 of those are actually 65 centimeter. They do have stowable forward hydroplanes. This was one of the first Russian submarines, and they may have even predated the United States in having retractable bow planes. Yeah, they use that first. So right behind that are the escape hatches. This is basically how the crew would get in and out of the boat when it's on the surface or in port, or they could escape out these escape hatches, but there's a better way of escaping from the submarine that we're going to go over here in a minute. Number 7 is the sonar compartment. They had shark gill sonar, which was one of their better sonar systems. Very impressive that they spent the money to put it on this thing. This thing was like a golden child in terms of design. They put their best ideas, most expensive, top-of-the-line equipment, bow to stern in this thing, and that included the sonar system. All right, behind that, you see the row of 10 silos. There are in pairs of 2 for a total of 20. That's where the R-39 ballistic missile tubes are. Number 9, right behind that, is its own pressure vessel by itself. The rest of the submarine could flood out, and you could lock this room up, and that is the control room. You control everything, including shooting the torpedo tubes and changing the course of the ship from this one compartment. You don't need to be anywhere else in the ship. The Soviets were really big into automation early, and they wanted to do everything from one centralized location. And like the Papa and the Akula and this Typhoon, they planned it and built it that way. So the control room can do everything. But having said that, you can also go locally to the torpedo room and back aft and control things locally. So you have multiple ways to control the submarine, all in one spot or from each individual station. So 10 is another escape capsule that goes up to, these escape capsules are in the event of a casualty. If the submarine is flooded out and you need to escape the submarine because it's sunk or sinking, you get the crew into these escape capsules. There's port and starboard, one for each of those long pressure hulls, and they can pop it to the surface. Very positively buoyant, full of rations and fresh water for the crew for a few days. Has a distress beacon, a radio, and an underwater telephone, and will keep the crew warm, in really cold waters. And there's 2 of them. All right, behind that is number 12. That's the fin. And behind that is the radio room, and the reactor compartment is 14. So not a whole lot of details here other than notice that each pressure hull, port and starboard, has its own reactor and is completely independent of each other. That's really all you need to know here about this. It's pressurized water cooled, and creates steam for the turbine generators, spins the screw, and that's basically how that works. Not going to go into a lot of detail here. Okay, 16 are protrusions topside that prevent ice from damaging the propellers. A lot of people seem to think that these are scoops or inlets or something that brings water into the sub. No, it's there to break ice so that ice doesn't slide down the aft end of the submarine right into the screw, damaging the screw. That's all that's there for. All right, let's move out into general layout 2 here. We're moving on to 17. That's the turbine compartment, and 18 is the machine compartment. Multiple watertight compartments throughout this entire thing. 19 is the hydrodynamic vortex smoothing protrusions, which is, we call it the vortex dissipator in the United States. There's different ways that these work, and the hydrodynamic vortex smoothing protrusion is basically a Google translation gone awry. Just think of it as every screw blade, whether it's on a submarine or it's on a surface ship, but it's more dynamic on a submarine that's submerged deep, creates a vortex right behind the screw, and that can add cavitation. It can make noise. It does technically have a slight amount of drag, but even though that's not really measurable. So having these vortex smoothing protrusions helps dissipate that. 20 is the vertical stabilizers, and 21 is the rudders. Notice there's rudders on the top, above the screw, and below the screw all at the same time. 23 is the aft hydroplanes, which are like control surfaces. And 24 is a sonar. That's the shark gill sonar. We're going back to the bow now with 24. If you're looking around the aft end, we're back to the bow. Now we're going to go along the bottom of the submarine and talk about what those are. 25, right behind the sonar system and behind the torpedo room, is a stowable thruster. This thing was so big, it needed to have these little retractable thrusters to help spin it in and out, around it at low speeds. You would only use these if you were like less than 3 knots. Basically getting away from the pier, pushing yourself out into water where you could begin churning the big screws and pushing the boat forward down the river. You could get underway with these without tug assistance. That's their primary purpose. If war hit and the tugs were unavailable because they're either sunk or they're getting another ship out at sea, the captain and the crew could get on this boat, drop these thrusters, throw off the lines, and push themselves away from the pier. They're also very good for station keeping, but they're very noisy, so they would not be wise to use that, but they did actually use them. And they're very detectable. They are not quiet at all. Quite as submarine Russia builds, and they've put on these freaking stabilizers, stowable thrusters that they use for station keeping that make all this noise. It's ridiculous, but Comrade's going to follow the procedure, I suppose. All right, back to the missile compartment. 26 is the missile compartment there. What's important to understand about this missile compartment is free flood water around the tubes. A lot of people watch that wonderful movie, Hunt for Red October, where they're having a gunfight in the missile compartment. That's complete baloney because they would be in water if they did that. So you cannot even see the missile tubes from inside the submarine. Okay? So there are 2 OK-650 nuclear reactors that turn propeller shafts, which is number 29. 30 is the horizontal stabilizer. 31 is the pressure hulls, 32 and 33. You can see that there is 5 different pressure vessels here. I suppose you could say 7 if you counted the escape trunks, because technically those are pressure vessels as well. All right. And then 36 is a rapid dive tank. And I don't care what they call this tank. This thing took 20 minutes to dive. I've seen it. I've watched it. I waited for it. It is a slow beast. And once it dives, it's still slow. This thing never moves fast because it's enormous. It's so big. It's pushing 26,000 tons, not pounds, but tons of water out of the way, submerged. So everything about it is slow. All right, enough of that. Let's talk about weapons. So the only defensive weapon this thing has, besides maybe shooting a torpedo at another submarine, is the man-pad system. They had the Strela 3, which is the shoulder-launched from a crew member surface-to-air missile, very short range. Think Stinger missile, essentially, shooting up at any helicopter or aircraft that might be overhead. And if you're doing that, the thing's already dropping bombs or torpedoes on you. You're just basically getting revenge at that point. Forward of the sail there is the large missile battery, 20 R-39s or RSM-56 Bulavas, ICBMs, and the Test 71 heavyweight torpedo and Type 53 heavyweight torpedo that we will talk about in detail, I promise. We're just not there yet. All right, countermeasures. So the NACAT-M Watchdog ESM is a very good ESM. This thing, as soon as a frequency hits it, it measures the frequency, it gets its best direction, it categorizes it as whether it's a surface search, air search, is it a threat or not, type radar. Watchdog ESM, groundbreaking technology for the time. Snoop Tray. They ran Snoop Tray all the time. They did not care. It must have been in a procedure. Every time they surfaced, they would start radiating this thing. Made it real easy to track, besides it being noisy as hell. But the radar guys were always happy because every time we got Snoop Tray, we were like, well, she's over that way. Let's see, MG 34 and 44 torpedo decoy launchers. These are externally stowed mobile decoys. Didn't even know that they had them until they used them during a war game. We're like, what the hell's that? Oh no, they've got something new. Years before we put it on submarines at least in the United States. Oh my God. So these guys were ahead of us again. I tell you, it's a miracle we won the Cold War. I'll just be honest with you, because the technology they were putting on submarines they were giving us ideas. We were like, we should do that. What they were already doing successfully during a war game. Mobile decoys, externally stowed, 6-inch. And then, of course, the SCAT sonar suite, which was okay. We did have better sonar than they had. Okay, so let's talk about the 7 planned, 6 built ships. They were all built in the Sevmast shipyard, which is up there in near the Kola Peninsula, White Sea, and they were commissioned between 1981 and 1989. They built 6 of these in 8 years. Yeah, finished 6 of these. That's some moving, because these things are huge. These take enormous amount of manpower and resource just to build one, and they were pumping these things out every year to every other year. Basically like a year and a half between each one if you averaged it out in the 1980s. And they were ahead of us in lots of little things, like those decoys I was telling you about. All right, that's a map of where they are. That's Sevmast Shipyard. Very popular shipyard, very active today. Still makes submarines and ships, but submarines famously come out of here because this one can build nuclear reactors and all that stuff and refuel them. You can see right there in the picture, there is a Typhoon right in the center next to the pier. That looks like the Dmitry Donskoy, which is the last one to be decommissioned. She is decommissioned now, but they used her for a test platform for many, many years. Okay, so here are some great pictures, and I apologize to those of you just listening, but this is the keel laying ceremony and the early construction of Hull 1 of the Typhoon. And you can see the propaganda posters are everywhere. They got, Stalin, Lenin, and Trotsky, and, hail to the worker slogans all around. And so, but just gives you an idea of just how big this thing is when you look at the people in these pictures and how enormous just one of these pressure hulls are. And they had 5 of these things all bonded together under a steel shell. This is the aft end of the ship. You can see they haven't installed the shaft or the screws yet, but they have the ring around it. And that was to protect the screw blades. It also helped make it a little more efficient. I love the picture on the right where you can see the port and starboard pressure vessels with all the reinforcement rings around it. That gives you an idea of just how strong. Okay, Project 941 Typhoon by the numbers. Let's begin with the power plants. You have 2 OK650 pressurized water reactors creating 380 megawatts. That's a lot of watts. Turning 2 GT3A turbines for 60 megawatts and 2 emergency motors with 2 shafts. She displaces, over 26,000 tons submerged and can make 25 knots. And that is a public number that I believe is correct. I haven't personally seen her go. Hell, I didn't even see her go 25 knots, but okay. We'll say she can go 25 knots downhill. She has 20 vertically launched RSM-339 or RSM-56 Beluga ICBMs, the 4 53-centimeter torpedoes with 265, like I said, and shoots the combination of Test 71 or 53 series torpedoes. The weapons load included 22 weapons, like I said, and they would shoot the SAN-8 Gremlin or Strela 3 from the bridge if they had to. The Albatross, also called Snoop Tray 1 radar, was the primary surface search radar. And we're going to go into these, by the way. I'm just listing them for you right now. So the Nakat M Watchdog ESM, fantastic ESM. They were probably better than us in that one piece of gear. They had Park Lamp, direction finding intercept, which was okay. SCAT sonar suite, also called Sharkgill. And here's one, the MG519 ARF sonar, also called Mouse Roar active sonar. This was a very high frequency, technically not very high. Actually, it was. Okay, this was a very high frequency sonar that had short range and was designed to do 2 things. Detect ice, so you don't run into it, and detect submerged objects, preferably an American submarine, at very short range. And it had a button where you would, if you had a target, you could hit this button and it would send the fire control information, basically the solution is what we call this in the Navy, to the weapon, to the fire control, and then that goes to the weapon with one button. So with one button, you could go mouse war, button, shoot that fast. If you had the tube ready, the tube needed to be flooded and pressurized. You could get a weapon in the water in under 5 seconds with mouse roar. Mouse roar was terrifying if we heard mouse roar. Because one, it was so short range, you only heard mouse roar when you were right on top of the other submarine. And if you heard mouse roar, they probably got you. They probably can see you. Not necessarily, but they probably could. So, mouse roar, ejection pump noises, weapon startup, and you're in a world of hurt is usually how that played out. All right, so behind that, they did have a towed array back then, but that wasn't nearly as good as ours, but we called it Shark Tail. They called it Plamida. I'm probably butchering that name, but just know that it's called Shark Tail. So Mouse Roar, Shark Tail, Shark Gill is the mainframe sonar system up on the bow, and it was the best they had at the time. Not as good as ours. But the MG-34 and 44 tube launch decoys, very good. All right, let's talk about this pressurized water reactor. They had two reactors on board, completely independent of each other. One could have a horrible fault and fail, and they could still power the submarine, push it through the water, keep all the lights on, completely independent. Two shafts with a 50,000 horsepower each shaft. Crazy amount of horsepower, but that's because you're pushing 26,000 tons of water out of the way whenever you're moving this thing. All right, so here's some great photos of inside the reactor compartment. Those are the control rods that those guys have on. You can manually raise and lower those control rods if you wanted to and bring the reactor critical. That was a procedure. All right, this is the NACOT-M ESM, wide open electronic support system. NATO reporting name, Watchdog. This covered D through H band, which is 1 to 8 gigahertz. Basically, most of the radar bands up there. Use two antenna arrays and incorporates IFM capability. So IFM capability is basically industry speak or Navy speak for detecting a frequency, quickly classifying it and determining if it's a threat, also measuring its power level and pulse to see if it detected you and give you an idea of not only is it a threat, have you just been counter detected? IFM capability is very important, and that was inherent. It was built in to this system. It wasn't like something they had to add later. And this is in the 1980s. It was really good. All right, max range of 222 kilometers. Sure. Listen, if you could hit it with a radar, it could detect it. That's what you need to know about the range. All right. Albatross radar, also called Snoop Tray 1. It's so funny. Every time I say the word Snoop Tray, it just brings back memories of joy of how excited the radio men would get. Because radio men, they do more than just messages. They also listen to ESM. That's their other job. And so they love Big Bulge, Wet Eye, and Snoop Tray. Those are the radars that they like to listen for because they know that we're doing good things if we're near these radars. And so... yeah, had a lot of Snoop Tray reports whenever we were on mission. So this is a short range, surface search only, pulse only, range of 37 kilometers, I-band. They used it for surface navigation, but the fact that they're using pulse radar, which is low probability of detection, or it can be anyway, in the 1980s for surface search shows that even on the surface, they wanted to be stealthy, which was a little bit ridiculous because we could see them on the surface, but yeah. All right, here's the MGK 500 SCAT sonar system, also called Shark Gill, designed to detect, classify contacts, everything the sonar system does, basically, right? Can auto-track 12 targets, passive sensors across all bands. Yeah, I mean, it goes basically from 1 hertz up to 100,000 hertz. That's the sonar spectrum. You can even really go above 100,000 hertz a little bit, but that's generally the sonar spectrum. This did consist of a full suite of mine detection, ice and fathometer, top and bottom detection, bathymetry systems, which is measuring the speed of sound, salinity, temperature, and pressure of the water around the submarine. It had that built into it. It's all one system. We didn't do that in the U.S. Navy until the Seawolf came around in 1986, 88, something like that. Late 80s. They were actually employing this in 1981, so they beat us on that one too. All right, R-39 Typhoon, also called SSN-20. I know it as SSN-20. NATO named Sturgeon, intercontinental ballistic missile. They shot 20 of these. 16 meters long, 2.4 meters in diameter. First stage is 2.3 meters in diameter, so it's got a slight cone shape to it, but not much. But if you look at a picture of it, you can't even tell. But just a little bit thinner at the top half than it is in the bottom half. It can carry 10 multiple independently targeted reentry vehicles. And so basically it's going to blow up 10 things into 10 mushroom clouds per missile. And it carried 20 of them, so simple math tells you it can ruin your day. It is cold launched, which is interesting in that it doesn't ignite the engine in the tube. It actually is ejected via a gas generator, which overpressurizes the tube, pushing the missile out of the top of the tube. And because it does that with air, there is actually a bubble around the rocket motor as it goes up, the whole rocket. Now, people like to say it's launched dry. Okay, it's dry-ish. It's dry enough that it doesn't get, the electronics wet. It's still underwater, but it is surrounded by, millions of these little bubbles and big bubbles. And so mostly dry. All right, so that's the missile. Here's the RSM-56 Beluga. This is the new one. This is the upgraded one. And part of the reason why they kept one Typhoon around for so long was to be the test platform for this RSM-56 Beluga missile. This increased the range significantly to 8,000 kilometers. This is the one where they don't need to leave port to nuke the United States. That was a bit of an exaggeration, but I suppose if they went over the top of the world, they could do it. Yeah, Canada's definitely toast. Anyway, so the CEP, that's the amount that it may miss, is only 120 to 350 meters, which whenever you're talking about a nuclear weapon means nothing, because it can carry anything from 100 kilotons to 150 kiloton warhead. This is a big boom whenever these independent reentry vehicles hit you, and it's carrying 10 of these things. It's crazy. You don't need much bigger than 150 kilotons to level a city. And so that's the purpose of this thing. All right, here's the Strela man-pad system. Like I said, it's shoulder launched by, a crewman. He gets up in there. SA-14 Gremlin was the NATO name. It's man-portable. It's only 1.5 meters in length, very lightweight at 10 kilograms, 10.5 kilograms. It has a 2 kilogram high explosive warhead on it. It's infrared guided and impact fused. So it has to actually hit something for it to blow up, which it probably will be well. Very short range. Here's the Test 71 heavyweight torpedo, manufactured by Gidroper. Basically, Russia. Russia's making these. This is a 53 centimeter weapon, it can do anti-surface ship, anti-submarine, doesn't matter. 40 knots max speed. Okay, sure. All right, 40 knots max speed is the public number. Max depth is 400 meters. That's accurate. Large warhead, 205 kilograms. That will do the job, let me tell you what. And see, proximity and impact fuse. Also active sonar, passive sonar, which is terrifying. This thing can home in on you without making a noise. And it is wire guided. So the submarine fire control operators can steer the weapon left, right, up, down towards the target, make it do circles, whatever they want to do, and then unleash it whenever they feel like it. Very good weapon. A little bit better than the public numbers are. All right, here's the Type 53 heavyweight torpedo, 53 centimeter again, 51 knots max speed. So we're getting faster here. 8.5 kilometer max range, very short range, but it burns hot, so it goes fast, short range, impact and proximity fuse, again, wire guided, and all the usual bells and whistles. This is just an improved version of the Test 71, and it has a bigger warhead. This has a 2,000 kilogram warhead. This, I don't want to call it a carrier killer, but it certainly would do the job, I think. I think it would snap the keel of just about any ship. 2,000 kilograms is a lot when it's on top of you, right? This isn't something that's blowing up in the vicinity. This is going underneath your carrier and exploding. All right, final thoughts on the Typhoon-class. Man, it was built in response, like I said, to the Ohio-class. The Soviet Union was concerned. They were, terrified, if I can exaggerate a little bit. And they wanted to respond with something better. And they did in many ways. There were many systems on the Typhoon that were ahead of the United States in the 1980s. You have to give them credit for that. ESM, mobile decoys, fire control combat system integration to the level that they did on the Typhoon was still on the drawing board for the Seawolf in 1981. So they actually built it 5 or so years before we did. 7 submarines were ordered, 6 were delivered, 1 was unfinished. The Dmitry Donskoy was the last one and was a test submarine for years. So even though she was still commissioned, she wasn't actually doing ballistic missile patrols. She was out there as a test platform. The boats were double hulled, all built in Sevmash. We showed you a picture of that. All the boats were nuclear powered and carried strategic ICBMs. They did have torpedoes. And the mission of a ballistic missile submarine after it launches its missiles, if it's Winchester, is to become an attack submarine. So it could do that role. It would not survive, I think, the first encounter, but it certainly would get some shots off before it was sunk. And it could use the torpedoes as an area denial weapon. Like they could shoot those wake-combing 65-centimeter torpedoes in any direction, preferably towards a NATO fleet, and run the other way for an hour and get a head start. And so, not can outrun a helicopter, but you can outrun a ship that way. All right, the main propulsion system was the OK-650 reactor system. Remember, they had 2 of those, and this ship was replaced by the Borei-class that is now fully operational. I believe they're still building a couple more Borei, and it's just the 21st century ballistic missile submarine is the Borei-class. We do have a couple of old lectures on Borei. I should probably do a new one of those, and I think that's a good idea. Maybe we'll do a Borei after this so you can see how the transition from the Delta 1, 2, 3, and 4 that we've done through the Typhoon that you have here into what they have today, the Borei. All right, look forward to that. Again, thank you, Patreons and YouTube subscribers, members. You guys keep this channel going, and we do have a staff now that helps with these, and you guys pay their salary. So thank you very much for doing that. Have a great one, everybody. Bye.